My name's John Karcz. I'm a scientist at Ames Research Center nearby, and I'm a physicist. I'm partial to using simple ideas, try to come up with deep understandings of things from simple ideas. And with the charter, I've got a few in mind with the charter of the conference in mind. And we're asked to be talking at the workshop about ways to make progress in space rapid in the near term and the long term. And there's a few set of, I think, really simple ideas that are good to keep in mind persistently as we think about progress forward. And these are coming from the perspective of a space scientist, and then I'll back up a little bit from that afterward. One is a very simple idea that new commercial capabilities, new private sector capabilities are beneficial to science. That as the private sector gains the capabilities to do new things, those are things that we can exploit to expand the scientific goals that are within reach. We can attain new objectives because of new capabilities. And we've been hearing people talk about that during the meeting today. We've heard about what the implications of reduced cost for launch have been, and about the expectations for cheaper and bigger launch, and also for much cheaper launch. You know, we've seen over the last several years the people taking advantage of commercial capabilities to go to the moon, of thinking through how to use new commercial capabilities to go to Mars, to do landings on Mars, to put orbiters around Mars. Broadly, we've seen an expansion in what companies can do in small spacecraft and other spacecraft. People can do things cheaper, they can do things better, and that benefits what we can do in science. So that's one thought. The second thought is that science can aid the development of commercial capabilities. At any given moment, wherever the frontier is of human activity in space, at that frontier, one of the only users for capabilities is science. The notion of frontier in space is a little complicated. There are actually a bunch of frontiers. There's a frontier for planetary science. There's a frontier for astrophysics. There's a frontier for human activity. And within each of those, you can come up with little sub-frontiers too. So in an abstract though, wherever the very limit of the frontier is, science is typically the only demand, or a very rare demand. And what I think is important to keep in mind is that I expect both of those things to stay true for the foreseeable future, and that those complement each other very well. That by improving scientific capabilities, by improving private sector capabilities, you can improve science. And if you engineer and you think through the way you do scientific things well, you can drive an improvement in commercial capabilities as well. And so as we think about moving people into space, I think, and moving not just people, just moving all of our other activities, scientific, robotic, whatever, it's important to have those notions in the back of our minds to think about what's feasible. And what can be done. What does that mean in an applied way? What should we do based on that? One of them is, as scientists, we should be really thinking carefully about how to exploit new commercial capabilities. And that actually is hard. That when a new capability becomes available, it can take years for it to really sink in and for people to factor it into the way they design their work. I think it's important to really be deliberate about that. Second, for people developing new commercial capabilities, try to directly reach out to scientists. Try to think about, especially if you're doing something way out on the frontier, something really at the edge of what's feasible. Think about what the scientific applications are, and then trying to find the scientist who might be the potential demand, or the set of scientists, and try to view them as a customer. They may not be the ones with the actual funding. They might be going to a funding agency or philanthropist to do the mission, but they're the ones with the mission to be done. And so try to find them. to help advance your work. And then there's another comment, and that's for the government people, and that is to think about how to design programs so that they are compatible with both advancing science and with driving private sector activity, and try to avoid accidental barriers in there. And I would say that there has been a lot of that going on. There are certain programs that have been around. Just to pick two examples, the Discovery program does a pretty good job being compatible with both of these. And that's one. That's a program for robotic scientific missions. There's a bunch of others like that. There are programs for conducting lunar science missions and the like that have these thoughts baked into them from the start. It's not a new idea. It's a thing that's being applied right now. But I think it's a persistent thing, that wherever the frontier is, these things will remain true. So as we think about how to do rapid progress, we should have those in mind.
Oh, that's it. Wonderful, thanks. Definitely under time. Okay, awesome. Questions, comments? Yes.
Do you have a good example where the scientists were able to leverage a new commercial capability, and that might help?
Yeah. So there are a number. Right now, so a thing that I'm involved with is at the moment is the commercial lunar payload services program that's delivering scientific payloads to the moon. And so there are companies that are developing commercial capabilities to deliver payloads to the surface, and they're being employed to send scientific payloads. There are examples at many levels, but one is first of all, launch has helped everybody. But when you go farther out, the frontier for human spaceflight is low Earth orbit right now. And what we see is there are scientists who have been trying to exploit the suborbital vehicles to do new research that was hard to do either with parabolic flight or drop towers or sounding rockets. There are people who are just starting to use commercial capabilities for science in orbit. We're just starting to see the beginnings of that. And I think that'll expand as we see the capabilities increase. Like right now, there's work on developing commercial space stations. I expect to see the same thing hold there. I expect it'll take a little bit, but scientists will figure out how to take advantage of those and then really do more at them. But you can do similar things with getting into the weeds about capabilities for spacecraft or for communications and that sort of thing.
Okay, now we need your challenge.
I would say to try to find examples where you see a confluence like that happening, where you have an opportunity for new commercial capabilities to aid science, and that application ends up helping the commercial capabilities as well.
For science and commercial. Okay. Awesome. Thank you so much, John. Awesome.